Hi, I'm Charity from Ralubimba Secondary School. I need help with these questions.
Okay, thank you, Charity, for this question. I love these kinds of questions because the moment you have circles, you can use your circle geometry. Remember, it's not just triangles. You can use cyclic quads, you can use tangents if you have them. You can use all of these things to find the relationships. So let's check out this question. It is so great. Okay, it says, in the diagram, HLKF is a cyclic quadrilateral. Okay, that should immediately scream some theorems at you. This cyclic quadrilateral here, we know immediately has its own property. So we know immediately that K1 is equal to H1 and 2 because it's the exterior angle of that cyclic quadrilateral. And we also know that we have this angle here equal to this angle there because of cyclic quadrilateral, the exterior angle. Also said the chords HL and FK are produced to meet at M. So we have HL, which is the chord, and FK, and they've both been extended to meet at this point M outside the circle. The line through F parallel to KL, okay, so the line through F, which is parallel to KL, meets HM, which is this whole line here, produced at G. So if we extend HM, it meets this line here at G. Lastly, it says that MK equals X. This side here measures X units. KF is equal to 2X, so that's this side here. ML equals Y, which is this side here. And LH is equal to HG, which is what these signs notify over there. Okay, so let's take a look at what we have to prove. Firstly, it says, give reasons why angle GFM, which is G, F, and M is all the way up there, so that's this angle here. Give reasons why that angle is equal to LKM, which is this K1 over here. Okay, so immediately you should recognize that you have parallel lines. If I just draw out the parallel lines here, they're saying, why is this angle equal to that angle? Very easy, simple explanation. They are corresponding angles. And FG is parallel to KL, and therefore the corresponding angles are equal to each other. Okay. Secondly, it says prove that GH is equal to Y units. Okay, so we've just proved that this angle is equal to this angle. And it says prove that GH is equal to Y units. Okay, so this is where your proportionality comes in. If we have this big triangle here, F, G, M is over there, and then we have KL parallel to this side. We have X over here, 2X over here, Y over here, and then this side is divided in half. And H is over there. Okay, so they're saying prove that this side is equal to Y. Well, immediately, because we have parallel lines, we know that these sides are in proportion to each other. So firstly, we can say MK over KF is equal to ML over LG. So basically, this side over that side is equal to this side over that side. And the reason is line parallel to a side of the triangle. Okay, because remember, this side parallel to this side divides the other two sides in proportion. So now we can substitute in our variables. MK is equal to X. KF is 2X. ML was given to us as Y. And LG is the side that we're trying to find. Okay, so you can simply see that if we have 1x over here and 2x over there, we have 1y over here, therefore LG is equal to 2y, because 1x to 2x is 1y to 2y. But that's not what we have to prove. We've proved that this whole side here is 2y. But now we have GH, okay? So we've proved that this whole side here is 2y, and we were given that GH is equal to half that side. So now we can say, but GH is equal to a half of LG, and it was given to us. And therefore, GH is equal to y. Okay, easy peasy stuff. Thirdly, it says, prove that triangle MFH, which is this big triangle here, MFH, is similar to triangle MGF. And that's an even bigger triangle, MGF. Okay, so now we don't have enough information about their third sides to use sides in proportion. So we're going to have to prove equiangularity, or just that all three of their corresponding angles are equal. So let's take a look at this. We have in triangle MFH and triangle MGF. Always lay out your similarity arguments like this, guys. It makes it so much easier for your examiner. Okay, so in these two triangles, I can immediately see that this angle M is common. Secondly, we're going to have to do some manipulation with our angles. Let me take this out so I don't complicate my diagram. Remember we said that this angle is equal to this angle because of corresponding angles. But also remember, right at the beginning I said because of this cyclic quadrilateral, K1 is also equal to this angle over here, external angle of a cyclic quad, which means that this angle is equal to that angle, which is two angles in these triangles that we're trying to find. So firstly, we need to say K1 is equal to MFG. This angle here is equal to this angle here. And you can simply say proven, because it was proven in question 1. And then you can say K1 is also equal to MHF because of external angle of a cyclic quad. And therefore, angle MFG is equal to angle MHF. Okay, so we've proved two of the angles are equal to each other in the triangles. So lastly, we can just say that angle, it would be MFG, which is this last angle. Okay, not MFG. We've already used MFG. It would be that this last angle here, MFH, is equal to this last angle here, MGF, because of remaining angle. And therefore, you can conclude that triangle MFH is similar to, let me double check, MFH is similar to MGF. And don't forget to give a reason why. In this case, it's angle, angle, angle. Okay, so remember, try and list your triangles in terms of their corresponding angles. Angle M is equal to angle M. Angle MFH is equal to angle MGF. Okay, so you label them correspondingly. It's going to make it so much easier for you guys. Fourthly, it says prove that GF over FH, GF over FH is equal to 3x over 2y. Okay, so firstly, we've just proved triangle MFH is similar to triangle MGF. We've just proven that. Okay, so if we look where these two sides sit, we've got triangle MFH, FH, and triangle MGF, MGF. Now remember, because of their correspondence, this angle here is equal to that angle there. This angle is common, And lastly, this angle is equal to this angle. Okay, so the sides that we're trying to prove, it says prove that GF over FH. Okay, so GF falls over here in this triangle, and FH falls over there. So it is the corresponding bottom side of the triangles. Okay, so we can immediately say that GF over FH, if you want to use this as an argument, you can just say that we've proven this. GF over FH is equal to, we're trying to find a side that is 3x and 2y. Okay, so 3x as a side is MF, and 2y as a side is MH, because remember we found that these are y here. So we're looking for MH and MF. So MH falls over here, and MF falls over here, and they are also corresponding sides. So you can say is equal to MF over MH. If you wanted to use your similar triangles up here, you could say GF over FH, which is a corresponding arc, is equal to MF over MH, which is another corresponding arc. See, that's why I say you must list the vertices in their corresponding positions. If you list them as they correspond to each other, you can draw these arcs and match them, and that's how you get your similar ratios. That's why I drill listing them in their corresponding vertices. Okay, so let's finish with this proof. GF over FH is equal to MF over MH. MF is this whole side here, which is 3x, because x plus 2x is 3x, all over MH, which is y, plus another y, which is 2y. And that's easy peasy. Nice proof over there. That's exactly what we're looking for. Okay.